Okay, I sent a message asking about the exams time, so I will let you know once I get the feedback. Um, Last class we discussed about shifted uniform series, and we saw how you can use it for calculation. And then we looked at a scenario when you have the uniform series shifted and then there is a single variable in between. That is something like this. You have all of this amount, they are uniform because they are the same. All of them is 5,000, 5,000, 5,000. They have the same height, the same length, if you want to put it like that. And somewhere in the middle at point 8 or at the year 8, you have a random single amount, which is around 2,000. So you will see how you can use it to calculate the present total, this kind of scenario. So we even gave an example and so on. So we will, today, I will ask now. I sent a message, they will reply back. Yes, I am getting your homeworks. A lot of people are sending their homeworks to me, and I am getting them. So if you did not send it, then do that as soon as possible because if the deadline passed, then so I get the homeworks. All of you guys are doing good in the homework. So today we will look at shifted arithmetic gradients. We finished shifted uniform gradients. Then today we'll look at shifted arithmetic gradients and also shifted geometric gradients. So let's start with the shifted arithmetic gradients. For shifted arithmetic gradients, it's gradients that start and that begins at a time other than between period 1 and 2. So something like this. This is period 1 and 2. So the gradient did not start at this time. So it started somewhere around period 3. But that is when you have 60, 65, 70, 75. So it's increasing it starts increasing from period 3. So that is it. If you start it at any period other than period 1 and 2, then you call it a shifted arithmetic gradient. It has shifted, it has moved. So in this case, you can calculate the present worth, that is the PG, is located at period 2, is located period 2 before the gradient starts. So if you are asked to find the P-word, that is the PG, this is the time the gradient starts. So this will be somewhere around here. So you move 2 periods before the gradient starts. That is when you have the pre-PG. You must use multiple factors to find PT in actual year 2. So all what you are doing is to find this PT, present total. If you want to find present total, then you have to use multiple steps. That is, first you find the P2, that is, you just assign it in any random value, you call it P2 or whatever, then you do the calculation, then you do another step, then you make another step, and then you sum them up. Just like the way we have in the uniform gradients, but this time around it's a bit different. So to find the equivalent A series, that is the equivalent A series, you have to find the present total in time 0, and then you apply this formula of AP, giving you I and N. Okay, then in that case you can be able to find the equivalent A series. So this is an example of a shifted arithmetic gradient. They said John Deere or Dere or whichever expects the cost of a tractor part to increase by 5%. So the cost will be increasing by 5%, $5 per year. Sorry, it's not percent. $5 every year, beginning from year 4. So if you draw your number line, then you count 0, 1, 2, 3. So it's beginning from 4 years from now. So if you are now at 0, then 4 years from now is somewhere around here. Okay, 0, 1, 2, 3. So this is where it starts from year 3. Then you start having the gradients. Okay, the cost in years 1 to 3, that is now they are giving you the amount. In year 1 to 3 is $60. Okay, so if you put uniformly, it is increasing in year one, $60. Second year, you got $60. Third year, you got $60. Then from the third year, it started increasing by $5 every year. Okay, so that is just the grammar, the English. So that is just the English. Okay, so the question says determine the present worth in year zero. That is the present worth in this year zero. Of course, through year 10. At year zero through this year 10, they are giving this interest rate of 12% per year. So you draw your number, you put your number line, then you look at where the gradient starts. You number it 1, 2, 3, 4, 5 until the end, and then you put your zero. So the solution is first find P2, that is at this point, yeah? So you have your gradients at this point, then you move one step backward if you remember what we did that the other time. Then you just put an arrow and you name it any number, an arbitrary number. So here you call it P2. For this gradients at $5 and base amount of $60 in actual year 2. So in year 2, you are given $60, the amount is $60, that is PA. You use PA because you are given this amount PA, and you try to find P. This 12% is the interest rate. And then now the number of periods, because you are counting now, is down, it will be 8 years. So you put it like this, then plus the gradients is also always 5%. Normally, we'll use this formula here. So you will be given gradients, you find P. So you put the gradients 5% here, you find P, put the interest rate, and you put the N, that is the amount. We already did this. You put the amount, which is $60, you find P given the amount, and then this interest rate, and then multiply by 8. So this is what you are trying to do here. So you have the gradients, which is 5. You find P given this year, that is 8 years now at this bottom number, and then this is 12%. So this is your P at year 2. So if you have P at year 2, which is this one, so this becomes future amount, yeah. The relation should be PT because this will be in the future, yeah. If you want to find P0, you move back to the 0 here, yeah. So the 0 here, you are trying to find the P, that is P2, given this future amount of $60, 12%, and this is because this is at year 2, then the number of periods become 2. So you put it like this, and then you find the value here. Okay. So if you have this guy here, now it is time to find this. So mind you, this P2 will be what will be this guy here, this value here. Get this $3, 3 whatever dollars. This is the P2 you just calculated. So next you find PA. Okay, the present amount for $60 amount in year 1 and 2. So the PA now will be $60. That is the amount given. You find P 12% for year 2 at this year 2. So this will be whatever this guy here, $101. So if you want to find the total now, finally add P0, this P0 that you calculated, and PA to get the present total. So this is how you do it. So if you are given a question and then you realize that it is a shifted arithmetic gradient, then this is the way you just follow this pattern to do your calculation. And how you know that it is an arithmetic gradient? Because it is increasing by a uniform amount. It is increasing by $5 every year. Okay. And how do you know it's shifted? Because it did not start from year 0. So you have to plot your graph to know exactly what kind of gradient is it. How do you know this is a uniform gradient? Because it is increasing uniformly, like this, like this, like this. How do you know this with a random variable? Because along the years you have a number that is different from the other numbers. How do you know this is just a uniform variable? Because everything is uniform throughout, like this one. Everything is uniform throughout. So you apply this kind of method to to do your calculation. So this is the formula again. You can have a look at it to be more conversant with it. So now we look at shifted arithmetic gradient. This is shifted geometric gradient. You know, if we said if it is a geometric sequence, that it is increasing by percentage instead of a uniform number. So last time with the last one, the arithmetic gradient, we said it is increasing by $5. Now this one, it will be telling you it's increasing by 12% or 13%. Okay. So shifted gradients begin at a time other than period 1 to 2. It's the same thing as what we just saw here. It begins from period other than period 1 and 2. So that is why it is shifted, yeah? The equation to find this PG is very easy. It's just a single formula for all cash flows with base amount A. Okay, is included. For negative gradient, the sign will change. So if you have a negative gradient, so these signs will change. Instead of having negative, you have positive, and we will show you a positive gradient. So this is a positive gradient. It's increasing positively. Yeah, it's increasing. But negative gradients will be decreasing just the way you have it. You will see shortly in the slide. It will be like this. So that is when you have a negative gradient. Instead of it to be going this way, then it will be going this way. So that is what they are saying. They said for negative gradients, the signs will be positive on both of the G values. So this is an example when you have a shifted geometric gradient. They said Wharton Steel signed a 5-year contract. So the contract they are signing is a 5-year contract to purchase water treatment chemicals from a local distributor for $7 per year. So the contract for 5 years is $7 per year. They have to go to this distributor to purchase some kind of chemicals for treatment of water. So from year 1 to 5, that is 5-year contract, the distribution is uniform. It is always $7,000. When the contract ends, that is at the end of the first 5 years, then the cost of the chemical is expected to increase by 12%. So the cost will be increasing by 12%. Okay. So if you say 12% of this value of $7,000, you add it to the $7,000, it will be a 6, and so on and so forth. That is how it will be increasing. For the next 8 years, so they are telling you now from year 5, you have to count 8 years. You have to put 8 years in the number line. So 1, 2, 3, 4, 5, 6, 7, 8. So you put 8 years from year 5. So that is what will guide you in constructing the table. So if an initial investment in storage tanks is 35,000, so this is the initial investment. So you put the arrow down. You have an initial investment of $35,000. Determine the equivalent present worth. That is the present worth in year 0 of all the cash flows at I is equal to 15%. So this is the interest rate for the total number of years. So if you want to put the numbers, now from up here, the usual numbering will start from 1, 2, 3, 4, 5. This is the 5th year when the contract ends. And then another one continues 6, 7, 8, 9, 10, until 13. And then if you want to start counting for the gradient, this thing is from this time. That is when it started increasing. But this is when you start having the gradients. And this is how it is increasing, 12%. So you put this number or arrow and then indicate that this is when you have 12% increase. And this upper one is the total interest rate for the whole period. Then you go this way. This is the same table. Gradient starts between the actual years 5 and 6. So this is year 5 and 6. And that is when you start having the gradients. These are gradients, gradient years 1 and 2. So if you want to start your solution, then this will correspond to year 1, year 2, and so on and so forth. And PG will be located 1 year before the time you start having the gradient, so to be at this year 5. So that's when you will have the PG. So now you have this guy here. We said you plug in this formula to calculate PG. Okay. Where is it? You use this formula to calculate PG, and this is it. The 7,000, which is the amount, using that formula, plus that is PG is equal to amount to 1 minus 1 plus G, the gradients, and then I, the interest rate, and the number of years, and so on and so forth. So that is how you do it, 9 years and so on, and then you calculate the PG to be $49. Now move PG and other cash flows to the year zero to calculate PT. So you have PG now, you need to calculate PT. So we follow the same process that we are doing before. You assume PT, this PG to be your future amount. So given the future amount F, you need to calculate P, which is this guy, this PT. And this P, that is P at 0, okay? So the future amount is what you calculated here, okay? This 49. So you put 49,000, P of F, 15%, and then this is 4 years. That is number of years between this place and this place. This is 4 years. So this is this guy. You are using this to calculate P0. And then this one is PA. You are trying to calculate the amount, the P given this amount. So your amount here is 7,000. Okay, so you put 7,000. You calculate P given A of 15%. That is the interest rate, and then the number of years is 4. So this is what you have here. That is the second expression here. And then this base amount, you add it up. So you have the base amount, you add it up to PG or PT, then you add it up to PA. That is what you will, that is what you, PA, that is the amount between year 1 and 4. And you sum them up together, and that will give you the present total, which is $83,000. And so this is what you will do. I so much hope that they will allow you guys to use the material in front of you, so it can give you a guide, because it is somehow confusing. If you have the material in front of you, then things will be a lot more, it will be less confusing to you guys. So this is it for shifted geometric gradients. Now, if you have a negative shifted gradients, just the way we said it, a positive shifted gradients, it will move this way, yeah, and then a negative shifted gradients will move this way. So if you have a negative shifted gradients, this is the way you can calculate the present total or whatever. You use the same formula that you used before, but only that you will the signs here for the gradients will change. So in the formula before, this place is positive. Now you will replace it with a negative sign, because it's a negative gradients, and this is positive negative in the other formula. Just this one, this is positive here. Where is the formula? So this is positive here, you put negative, and this is negative here, you put positive, and that is it. Okay, all other procedures are the same for positive gradient. So you use the same procedure that you used before for this positive gradients. So this is an example of a negative gradient, just a different way. You start the gradient at this position. So a year before the position will be your PG, and this will be your total. They're asking you to calculate future gradients, not they're asking you to calculate this present total, future gradients, and future total. So this is they're asking you to calculate like 14 or so. So if you are calculating PG, you do the same thing that we did in the for arithmetic gradients. Yeah, the same way for arithmetic gradients. You remember, you use something like this. Yeah, you do the calculation, you find the P2 at this point, then you do the same thing, just the same way. Okay, so this is now 700 is the amount. So solution, the gradient first of course before between year 2 and 3, between year 2 and 3, that is when the gradients occur. These are gradients year 1 and 2 for the, if you are doing the gradient numbering. And PG is located in gradient year 0, that is in the lower numbering, in the gradient numbering at year 0, which corresponds to the actual year P1, okay, which is on this scale. So if you want to calculate this PG, now you have the amount as 700 and 10% I, the number of period is 6, yeah, then minus, you are given the gradient now, which is $50 minus $50. This will be negative sign, okay, because you are putting, it is decreasing, so this will be negative. So that is just the difference. So you calculate P, so this will give you PG, yeah. And once you have PG, you can always calculate either this one or you calculate this one. So if you want to calculate PT, that is the present total, you have the future amount, which is this guy that you just calculated. You put it here, you do the calculation at year 1, okay, because it is at year 1. That is what you have. Then if you want to calculate FG will be, you will be given you are given the P now, okay. The P, you take it as this PG, you calculate F for 10%, this 6 years. So you do the calculation here, and that is what you will have. So this is in case if you have a negative gradient, you follow the same procedure here for your calculation. I really hope they will allow you guys to use I really hope you guys, they will allow you to use it as to do an open book quiz or exams or whatever. So this is another scenario to find factors values for untabulated I for n. So if you have I or n that is not in the table in the book, for example, in the book, you have different tables for different interest rates or for different n. So for example, you have for I is equal to 1%, you have another table for I is equal to 2% if you go to the back of the book. But sometimes you will be given interest rate of maybe not a whole number. So they will give you interest rate of 8.3%. So if you remember, if you look at this, it's 10%. This is a whole number. It doesn't have any decimal point. The same thing here is 15%. It doesn't have any decimal point. But sometimes you'll be given 15.2%, and there is no 15.2% in the book. So this is what we are trying to tell you. We are trying to say, if this I or n is not given in the table, then how will you calculate the values that you are asked to find, whether it is P or F or A? So there are 3 ways to find factor values for untabulated I or n. You either use formula, you use spreadsheet, or you go for the table and you do extrapolation. So if you are asked to find for interest rate of 2, then you have interest rate of 1, and then you have interest rate of 3, then you extrapolate. So this is usually difficult, but just for your understanding, you can always know that it is available. But the better you use the Excel formula function, or you use a formula. This is really easy, and you will get an accurate answer. But this one, if we extrapolate, you just get an approximation. So this is what they're saying. Formula or spreadsheet function is fast and accurate, while in extrapolation is only approximate. So they're encouraging you guys to use. So this is an example for untabulated I. So you are given interest rate of 8.3%, which is not in the table. N is in the table is 10, which is a whole number. And then they are asking you to find F given P. So you just try to remember the formula that we discussed on in chapter 1. I remember the formula to calculate F, something like this one, yeah. So if you are given P and you are asked to calculate F and you are given the N, so you just use this I will be 8.3%, and then you do the calculation, and that is it. Is very clear. It's straightforward. You can also use this Excel function. Okay, so you can use the Excel function, one of these functions, let's see what the question is talking about. So you can use this Excel function also to find the F, okay? So I think the Excel function is FV into bracket I, which is the interest rate 8.3%, comma the number of years, that is 10, and then 1 is the maybe the, so this is N, this is the I, maybe this would be maybe the value given, maybe P or something like that. So you use the formula, this spreadsheet function, and you can always arrive at the same amount, which is 2.2 whatever, 2.2 whatever value. But if you are trying to use an extrapolation, then you can find at 8%, then you look for the one at 9%, because this value is in between the two. So at 8%, this is what you have. At 9% is X. 9% 8.2% is X. And at 9% is 2.314. So if you have this, then you do the mathematics and you get a value which is around this. So you see this value and this value, they are somehow not the same, they are a bit different. And if you try to find the percentage error, you can subtract this from this and then you multiply it and have like a 0.08%. So it's not always accurate and it's somehow tedious. So it's better you just use the formula or the spreadsheet function. And so also if you are given I, but you are asked to find N, unknown period N, for example, the book is given, maybe some periods of 2 years, whatever. So the same thing, you will use the same approach, like for a unknown recovery period involves solving for N, given I and two other variables. So if you are given one of these variables and I, then they will ask you to find N. So you can use this approach. So this is an example. They said a contractor purchased an equipment of $60. So the amount he purchased the equipment is $60. That is the money he used to purchase the equipment. That provided an income of $8. So the income in the book is providing is $8. So you just equate it with this. Every year he's getting this. So at an interest rate of 10%, that is your I, the length time required to recover the investment was closest to, and they're asking you the length time to recover this investment, that is N. So N is not given, but every other thing is given. So you just put it like this. You divide this 8,000 by 6,000, then you will have this guy here, okay? And then once you have this, you go to the table that has 10%, you look for the N that corresponds to this guy, that is very close to this value. So you go to the table 10 and that has 10%, then you look for N that has values that are very close to 0.1333, and this is between 15 and 14 and 15. So C is closer to the value. So this is how you do that. And then the last example I will show you is if you don't have the interest rate. So you will be given every other value. The N will be given and two other variables. Maybe you have P and F or A. Then you look for a suitable table. Maybe you use P given F, or you use F given P, or you use A given whatever to look for P, to look for the I. But this is an example. A contractor purchased an equipment of $60,000, and this equipment provided an income of $16 every year for 10 years. So you have N is equal to 10. You have this guy, his input, that is the P he is putting in. So you have $16, which is this value here. So you put, you have P, which is $60. You are looking for A. You have P. You have N. Then you are looking for I. So you divide what you have here by this value, and this is what is left. Then you go to the table that has n number of time, and you look for a value that is close to 0.22, and that will give you the corresponding interest, which is very close to maybe D. It's between 22 and 24%, let's say, if you go to the table. So you will have the value, and then you put your answer there, that is corresponding to what you have. So these are the scenarios we have. Just to revise what we did, in a scenario where you have shifted series, then the amount will start, or the given value or whatever, it will start a year other than period one. So it's shifted. And this type of series, you can have a shifted uniform series in which all the values will be uniform. That is, they will have the same length, or they will have the same amount. This is when you call it a shifted uniform series. Shifted single random single amount is when everything is uniform, but somewhere down there you have a value that is different from other values. And also you will have shifted arithmetic gradients. They are arithmetic gradients, but it starts from sometimes away from period one. So this one is starting from period three, which is not the same as period one. So this is the method that you follow to do this kind of solution evaluation. And also, if you have a geometric gradient that is increasing by percentage, from the question is given by percentage. So you construct your table, number line or whatever, and then you start doing it in this way. For negative gradients, everything will be the same, just that where you have the G, the sign will be different from what you have the G at the positive gradient section. And so this is it, the way you follow to do it. Sometimes you'll be asked to find I or N that is not tabulated. So in this case, it is easier for you to use the formula or just use the spreadsheet function. I prefer using the spreadsheet function for calculation. So that is it for today, and I will send you all the information I get from my colleagues regarding the exams. I will send it to you on the announcement section. Okay, when is the exams? What time is the exams? And all what you need to know. I will send it to you. Okay. So do we have any question? Okay, guys. If there is no any question, then have a nice weekend. Inshallah, I will see you next week. Okay. Yes, I will send it today. Inshallah, I will send you the details today. Okay. You're welcome. Have a nice time.